The oil industry is spending millions of dollars every year trying to sow doubt amongst the populace and try to obscure the scientific message and to try to sell people the fact that there's scientific uncertainty in this. It's the same tactics that big tobacco used before they crashed and were sued for all the damage they did to people to make money. The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective addressing important societal issues. Hello, I'm Dr. Al Scott. Welcome to another episode of The Rational View. On this podcast, I'd like to talk to you about the evidence for anthropogenic climate change. Now, for those of you who are just getting involved in the debate, the word anthropogenic is very large and may throw you for a loop. Anthropogenic is just coming from the Latin anthro meaning man and genic created by. So anthropogenic climate change is climate change created by the actions of man. Now, if you're a scientist or are interested in science and you listen to scientists, you realize that this is probably the biggest problem that's facing the human species as a whole right now, is the fact that the climate is changing, and the experts who study this issue say that we've got less than 10 years to fix the CO2 emission problem that we have. So if you've been out there looking on the internet, you've obviously seen the sort of polarized political rhetoric that passes for debate on this issue. And I'd like to just help you, to help me, to fight this battle. The battle is one of ignorance. And we have an opposition who are basically been sold a lie, a caricature of science, and they're not questioning it. We need to get in their faces and help them question it. And I'm going to have a podcast a little later on to help you with debating tactics. But first, I want to help you with the basics of science, because you shouldn't be debating unless you know the basics. Once you know the basics, then you can look at how you can engage and enlighten these people in a manner in which they'll actually listen. If you, like me, believe that this is important, then please like, comment on my post, and share it to others, friends of yours that you know would benefit from this podcast. We need to get the word out, and we need to build up our team. So, climate change. So the problem is that some people don't believe the climate change is changing. They say it's a hoax. And why does this even happen? As a scientist, I often wonder how people can be so ignorant. But the people aren't ignorant. They just aren't thinking. Their echo chamber is selling them this caricature, and very few are willing or have even the time to venture outside and actually engage in a discussion on the facts. So, let me help you to understand the straw man arguments that these people have been fed by their leaders. These will get thrown at you all the time. You need to ignore name-calling, take the high road, and stick to the facts. Here's a few that you're most likely to encounter. Someone's going to say, "Oh man, it was cold yesterday. It was snowing. It's cold, so, colder than usual. Obviously, the climate's not changing." Well, this basically shows a basic fallacy of weather versus climate. Weather is the day-to-day variations in the temperature that we see. Climate is the long-term average, the long-term global average. Even in a warming climate, there are places that will get colder than their typical areas because climate patterns are changing. There's more energy out there. The polar vortex is expanding during the winters. We have colder, longer winters due to the extra energy in that polar vortex, right? It's not just a simple linear march that everywhere is getting warmer all the time. So, some have been convinced that climate change is just part of a natural cycle. Oh, the climate has changed before, they'll say. Well, yeah, sure. We all know that. But as though scientists haven't been warning us, this has been about to be a problem for the past 35 years, right? Oh, really? It's changed before. Oh, we didn't realize. It's the scientists, dummy, who figured this out. Of course it's changed before. It's changed over millions of years, or hundreds of thousands of years at least. The problem is that this climate change is happening in years and decades, and not thousands of years or hundreds of thousands of years like it has in the past. And the problem is that stuff just isn't going to be able to adapt. Ecosystems could collapse. We're going to have deserts. We're going to have problems with our food supply. We're going to have problems with our water supply. People are going to starve. And that's not the worst that could happen. Another thing to think about is that the orbital cycles, which typically govern variations in sunlight reaching us, are called the Milankovitch Cycles. And they should be right now pushing us towards another ice age. The periods of these cycles, these Milankovitch orbital cycles, are on the order of 41,000 years and 100,000 years, and they've been identified many years ago, back in the 1920s, I think, was the original discovery. So, people know that this is around. We know it changes. Yes, it's not a significant discovery that the climate has changed before. That's not the problem. Another argument you're going to get is people saying that, the CO2 in the ice core data lags the warming. And that's true, actually. There was a science paper published a while back that measured tiny bubbles of air trapped in ice cores in the Antarctic ice sheet. And they know basically how many years ago each inch of ice corresponds to. And they can go back about 400,000 years and measure the variation in CO2 levels in the atmosphere over this period. And comparing it to temperature records from proxies, tree rings over the last 10,000 years, and other markers that people have been able to deduce over the past hundreds of thousands of years, yes, they have shown that the temperature increases and then the CO2 comes up afterwards and lags the temperature changes. And people say, well, this means that CO2 doesn't drive climate change. And that's true. Historically, the Milankovitch orbital cycles are what's been driving climate change. The orbit changes, the amount of sunlight the Earth receives changes, and the temperature changes. The reason the CO2 levels have historically lagged these orbital-induced changes is because as you heat the ocean, less gas can be held in the ocean. So CO2 comes out of the oceans when they warm up. So the orbit has been driving and the CO2 has been following. Now, the CO2 coming out of the ocean accelerates. There's a positive feedback, but it hasn't been driving in the past. That doesn't mean it's not driving now. All of these historical levels that people have been measuring over the past 400,000 years have been less than the current, significantly less than the current amount of CO2 in the atmosphere. Other arguments you'll hear, it's the sun. Well, no, it's not the sun. The sun is not getting hotter. We know that. We actually measure the output of the sun, and it's not getting hotter. So that is not the actual case. It is getting hotter over hundreds of thousands of years, but certainly not over on the time scale of the current heating, and it doesn't have any real resemblance to what's going on. Other people will have this argument from incredulity. They'll say the atmosphere is too big for us to affect it. And this is just, argument from ignorance and doesn't really deserve much of your time. The fraction of CO2 increase that we measure in the atmosphere is consistent with human activity. There's nothing here that can't be explained by burning millions of barrels of oil a day that we're doing. Others will say, scientists have been predicting ice ages back in the 70s. Now they're predicting heating. Scientists don't have any idea what's going on, right? They keep changing. Well, yes, it's true, science does keep changing. But scientists in the 70s were not predicting ice ages. There was a seminal paper back in the 70s on the orbital forcing from the Milankovitch cycles that showed convincingly that they could be linked, so that the ice ages, the past ice ages, could be linked to these orbits. And the current orbital cycle that we're on should be leading us towards another ice age. This was the paper that came out back in, I think, 76. This was picked up by the press and widely circulated. So yeah, that was a great discovery. Yes, we should be heading towards an ice age if we aren't polluting the atmosphere with too much CO2. Most scientists of the time recognized the CO2 issue as the major one, and most of the papers in the scientific literature were about that and not the ice ages. Now, another one I've heard, it's volcanoes. Yes, volcanoes do spew carbon dioxide into the atmosphere. And people will say, well, we haven't been measuring all of the outputs of all of the volcanoes in the world. No, we've only measured a small fraction. But based on this small fraction of volcanoes, we have a range of uncertainty, and we can estimate that volcanoes produce at most 1% of total human emissions. And you can compare the volcano major eruptions with the carbon dioxide cycle, and they don't track. So there's not really very good any likelihood that volcanoes are spewing much, unless we're out by 2 orders of magnitude in how much carbon dioxide we're producing and they're producing, and I don't think that's very likely at all. I've also heard people, the meme going around that Canada's forests absorb more carbon than we admit. We don't have to do anything. Well, this is patently untrue. Yes, a growing tree, a growing forest, new growth does absorb a lot of carbon. A static forest doesn't absorb a whole lot of carbon. And in fact, what happens is that the carbon becomes built into the wood, right? The tree sucks in carbon, builds wood. Eventually, a forest reaches a steady state, and trees start dying and giving off that carbon dioxide back to the atmosphere as they decay. And they reach an equilibrium point. And forest fires significantly add CO2 to the atmosphere. So these people don't even think about this, right? They're following their caricature. A tree, when it grows, absorbs this much carbon dioxide, and we have this many trees. Yes. But some years, our forests are net contributors to the CO2 in the atmosphere, and some years they're a net sink, right? It's very, it oscillates quite a bit from year to year, but it certainly does not approach the amount that people put into the atmosphere in Canada alone. Canada is a significant contributor to the global CO2 budget. We have way more than our per capita share we add to the environment. With such a small population, we're on the order of 1 or 2% of the global CO2 is coming from our small population. So we should be leading on this, as we are a relatively rich country, and we have the means to make these changes. The misinformation out there is endless. The oil industry is spending millions of dollars every year trying to sow doubt amongst the populace and try to obscure the scientific message, and to try to sell people the fact that there's scientific uncertainty in this. It's the same tactics that big tobacco used before they crashed and were sued for all of the damage they did to people to make money. So what are the facts in CO2? Well, back pre-industrial times, the CO2 concentration in the atmosphere was on the order of 280 parts per million. Okay, so that's not a lot. But right now, the current CO2 concentration is 415 parts per million. So we've increased from 280 to 415, mainly by man-made burning of fossil fuels. Now, the greenhouse effect basically works where the sun heats, the sunlight shines on the surface of the planet, visible light comes down, it's absorbed in the surface of the planet. The surface of the planet gets warm. It emits heat back into space, and it comes to an equilibrium temperature. Now, the heat is infrared light, so most of the sun's energy comes in as visible light. through the transparent atmosphere, and then the infrared goes back out through transparent windows in the infrared. But carbon dioxide has a significant absorption peak in the infrared where thermal radiation would otherwise escape to space. And this gas then absorbs this heat and doesn't let it escape. It acts like a blanket in the infrared, trapping the heat, like clouds do at night. You notice on a cloudy night, it's warmer than on a clear night because the clouds also keep that CO2 from going away, or keep that infrared radiation from going away. Another thing that we know of that points to fossil fuel burning as the cause of the increased CO2 concentrations in the atmosphere is the isotopic signature of the carbon dioxide in the atmosphere. We can measure this, and it is consistent with the sort of carbon 13 to carbon 12 ratio that we see in fossil fuels, and plants in general have a lower level than the atmosphere typically does. And also we can tell that this is caused by burning is because the oxygen levels have been decreasing by the same levels that the CO2 levels have been increasing. And this is a direct signature of burning. Other people will tell us that it's not bad to have a couple degrees of warming. I don't mind if it's a couple degrees warmer. That will feel, really good. I'll have a little bit less snow and a little bit more sunshine, and that's great. And the problem is sure, on average 2 degrees doesn't seem like a lot, but it's significant in the impacts that it will have. It's too fast. A couple degrees in the long run probably won't be bad, and over thousands of years, changes of a couple degrees aren't unexpected. And ecosystems will shift north and south to compensate as the temperatures change slowly over geological times. But the problem is that it's happening too fast, and trees and plants can't move fast enough to keep up with this. So what are the problems with CO2 levels going up and climate change? Well, there's a lot of problems. Obviously, we have to worry about ocean acidification. Increased carbon dioxide results in increased carboxylic acid in the ocean, which means that the ocean becomes acidic, which means that animals that use carbonates in the water to make shells are suddenly unable to make shells, and they become preyed upon and they go extinct. So we expect large extinctions in the ocean, changes in coral, die-offs, as well as lots of extinctions on land. Oxygen sources. Well, the ocean is a big oxygen source. We have phytoplankton which take in sunlight and the surface of the ocean and create oxygen. It's a significant source of the air that we breathe. Hopefully those type of ecosystems are not susceptible to these sudden changes in the ocean temperature and pH level. Otherwise, you could see, significant changes in the global oxygen level. We can see possible problems from meltwater from the glaciers in the Arctic. A significant pulse of fresh water in the north will change the thermohaline circulation, which powers the Gulf Stream, which brings warm water to Europe, and will change the climate of Europe significantly. You can think about all the positive feedbacks out there. You know what positive feedbacks are. A little bit of heating creates some change that results in a lot of heating that we can't control. Then you have this runaway greenhouse effect potentially. And obviously people are a little bit worried that, this is what's happening on Venus. We really don't want that to happen here. We know that there's a lot of methane trapped in the permafrost, which is now melting because of climate change. And what we have is there's a lot of plant matter that's been frozen in this permafrost for a long time, and this methane from all of the frozen plant life will suddenly be released as a big pulse. Methane is a much more potent greenhouse gas than CO2, and that's another risk that we're encountering is the fracking of shales to extract oil is actually releasing methane into the atmosphere through all of these new fissures and cracks. Loss of Arctic sea ice lowers the albedo. Right now, if you have lots of Arctic sea ice, it's shiny and white. It reflects the sun's rays back into space, so it doesn't heat up the planet as much. Now, if all that ice melts, suddenly you have dark ocean absorbing a lot of heat that would otherwise be reflected away. So this is a horrible positive feedback. And if the Arctic Ocean starts to warm up, there's a lot of methane clathrates frozen in the ocean floor, and this will bubble up and boil and cause another methane pulse, which has another positive feedback, which causes more melting, which causes more methane. And that's the sort of runaway thing that we want to avoid. Warming the oceans releases more CO2 into the atmosphere, like a warm can of pop releases all of its CO2. It's the same sort of thing. So it's a positive feedback. All of these positive feedbacks are why scientists are so worried in the IPCC panel that we need to stop this immediately. We need to get this down to net zero in 10 years or less, or we're risking unstoppable runaway greenhouse effects. So it sounds dire, but don't give up hope yet. There are things that can be done, and there is hope. If we pull together, we can solve this crisis. And please stay tuned, because in a couple podcasts I'm going to discuss what I think the solution to this crisis should be. I hope this has helped to give you the sort of background that you need to feel a little bit more confident in the climate debate. All of this stuff is available online. You can go and look at skeptical science sites and read up on this and teach yourself. So thank you very much for listening. I appreciate your time. And if you enjoyed this, please tune in again for my next podcast. That will be on how to debate against the forces of ignorance. Thank you and goodbye.